Hi, my name is Tim Lindquist. I'm a professor in the software engineering program at ASU. This is a video that supports our course SER423 on mobile systems. And today we want to talk about basic user interface with Android. This is Unit 3 of the class, and I want to go through a couple of the examples just to talk a little bit about to help you in terms of reading and understanding them and then applying them in the next lab exercise that you have to do. So if you look at the readings that are available, there's one on layouts, another one on the constraint layout, input controls, and how to build a UI in the layout editor or with the layout editor. We're going to take a look very quickly at layouts. So layouts are a view group that provide us with the ability to group together different components so that they stretch horizontally across the display or vertically on the display, or that they're laid out relative to each other. There's also a grid box. There's several different layouts. We're going to focus in the class primarily on two of them, not because they're the best or most commonly used, but just because they're good exemplary of the other layouts. The other layouts are also very useful, but we can't do everything. And there's no need to do everything. Once you figure out how to do one of them, then it's fairly straightforward to figure out how to do the other ones. So, so here they point out the difference between a view group and a view. Right, so views are things that you can put into a group, a view group. A view group has the ability to retain within it many different views. And it turns out that if I have a view group, one of the views that I can place into that view group is another view group. So it's very common to have a relative layout. Within that relative layout to have maybe a button, and then to have a linear layout also nested within it. So I've got a view group as the relative layout. Within it, I've got another a linear layout that may organize a label and another button or an image or other things of that nature. So views can be hierarchical, and when they get placed into a view, populated, and displayed on the screen, that hierarchy is maintained and it's used in order to take care of different situations, maybe different screen resolution, different screen sizes, and also orientation of the screen, portrait versus landscape. So views and view groups help us take care of that. And this particular reference shows you the XML that exists. Very different from iOS. In iOS, generally we work with a storyboard, and to actually get down to the level of it is XML, but to actually get down to that level, in fact, that's typically not done. So remember, with both of these platforms, views are not created by calling constructors at runtime, and instead are created by doing something that's very close to deserializing. In this case, it would be deserializing from an XML. Since it's strictly speaking not deserialization, it is something very similar to that. So it's sometimes described as expanding the XML into those objects that could have otherwise been created by calling constructors. So the reason to mention that is, first of all, that's the level at which you have to build your views in both of the platforms. But in addition to that, it's important to understand that you don't always have to just use the storyboard in iOS or XML or the designer in Android Studio. At runtime, you can create a new button and you can add it to your view or add it to a view group wherever you think it needs to be. When you do that, there's generally a lot of code that's involved because you want to set certain properties or attributes of the button object or text view that you've just created. So it's a little bit more difficult to do that, but it does provide for very dynamic user interfaces. So here's an example of a linear layout, and that linear layout contains within it a text view. Text view is the Android control for primarily placing a label, information that the user is not going to enter, but in fact is going to be under program control. A button gets depressed and gets selected, and it causes some action to take place in the controller. as an example. So there's a reference that goes through and explains layouts. There is actually on both platforms the ability to do constraint-based layouts. We'll talk a little bit more about constraint-based layouts on both platforms when we look at the issue of screen orientation, screen size, screen density, and how to design a user interface so that in fact it's the most adaptable. Sometimes we can have one XML file that works for 2 or 3 different. Other times we actually want to have multiple views that are selected based upon which orientation or based upon which screen size. We'll talk about that later on. So constraint layout is a new and evolving thing in Android. It's been around actually for a while in iOS. In my view, maybe a little more mature in iOS and more broadly used. Nevertheless, it is something that certainly in the future, if you're developing an Android app, you'll be using it. And then input controls. So here's a section on input controls, buttons, text fields, and checkboxes, and then building the UI with the layout editor, which is kind of a tutorial for doing that. There are also samples in this section, Unit 3, an alert view in Droid. In the first 2 units, or actually in the second unit, we looked at kind of building. We did it because we wanted to have 2 activities and we wanted to have an intent to go from one activity to another. But remember that we built kind of an alert dialog. This is a more accepted mechanism within Android for doing alerts. So it shows you an example of that. Another one of auto-completion text view, another one of input text, and then another one of a spinner. So a spinner is a control that it is a ball that you can spin, or maybe a cylinder that you can spin would be a better way. It's commonly used. There are special ones on both platforms for selecting dates and so forth, where the spinner has different segments. Set one segment for month, another segment for day, another segment for year as an example, and you spin them and then make a selection. I want to take a look at the input text Droid example because it'll allow us to, most of these I think are reasonably straightforward if you can download them, execute them, and read the code. And when you do read the code, the reason I want to go through it in a video is to kind of show you how to go back and forth between the XML and also the application and its behavior, the code, so that I think you'll get more out of those examples. So let's take a look at the input text as the first one. So input text Droid. Here's the example. Here it is running. We'll take a look at the code here in just a minute in the emulator. And it has 1, 2, 3 different, actually 4 different components and provides the ability for the user to enter information. So if in your emulator you don't get a keyboard when you execute this, let's first talk about that. All right, so if you go back to Android Studio and under the tools, Android, look at the AVD, Android Virtual Device Manager. And if you go to that virtual device, this is kind of hard to find, but nevertheless, you can edit it to make changes to it. And within that virtual device, you can make changes to its skin, which API it's using, and so forth. But if you go to Show Advanced Settings, there is a scrolled list. So is it start up in portrait or landscape? Does it have a camera, and so forth, network speed, all of these other things that you can do. But if you look down further, keyboard. So at the point of manipulating an Android virtual device, you can enable the keyboard on your desktop or on your development machine, and you can see that I have it unchecked. All right, so if I check it, then do finish. Now when I go back here, actually I may have to shut it down and start it back up again for it to take effect. I don't know if there's a better way to do it, so we'll quit. And we're done with the device manager. I'm going to go back and reset this in a minute anyway, but Let's start up the emulator again. This time when it starts up, it should see, oh, I'm allowed to use the keyboard from the, in my case, it's a laptop. I have to tell you that the Android emulator, every release gets better and better, and it comes up faster and faster. So now you'll see that when I select one of these fields, these are actually hints for the fields of what to enter in it. I can enter information on my keyboard. And using a tab takes me from one to the next. In this particular case, the release field, we'll see how to do this in creating the view. The release field, when you type characters into the release field, they won't go in. However, it will take a date. So 03/13/17, and tab takes me to the next field and so forth. It's very common to go back and forth. If you know of a shortcut for going back and forth instead of going through the virtual device editor, let me know. But I haven't found it yet. And let's go ahead and just shut this guy down, maybe. And we'll go to the device editor here. Set it back. I want to actually show the keyboards as well, because even though it's a little bit more cumbersome, it actually is. You really do have to get down to the level of working with the keyboard, the device keyboard, in order to do a good job of debugging an app. So let's go back to the advanced settings and disable it, so we end up with the keyboard that we want. And now starting it back up. Get out of this guy. So let's look at this project. In this project, the view is specified by a single layout file. In this case, it's activity_main.xml. We looked in the last video at how to do the relationship between that view and its corresponding controller. In this case, the controller is the main activity.java class. So right now we're looking at the view, actually we're not looking at, now we are. This is the view that we would see on the screen, and the controller for that view is that Java code. All right. So let's go and take a look at some of the details of the view itself, and then we'll look at how it gets controlled within the controller. The designer works very well for being able to pull things out and place them. As I mentioned, it's very common in Android, unless you're using some other multi-platform type of a framework, to spend as much time actually in detail messing around with the XML. So we're going to take a look at the XML here and look at some of the properties that we want to define in order to do that. And let's see, let's collapse that guy so we can look just particularly at the properties. So you see that I have a linear layout. One of the properties for a linear layout is its orientation. I've got that selected right now, and this is orientation vertical. The other orientation is horizontal. So if I wanted to nest things within a linear layout and have them appear across the screen, for example, as a row, then in fact I would make it as horizontal. And if I wanted those things to be lined up down maybe the left side or the center of the screen, then in fact I'd have it as vertical. So in this particular case it's vertical, and I've just got them all on the left side. What is kept within that linear layout and how are they positioned? It's based upon the order in which they're nested. Right? So literally, when a linear layout object is created at runtime to populate the view, that linear layout object has within it a list of views that are nested within it. And you can work your way through those views. You can add new views to them if you want to, or work your way through and find each of the different components that are in it. That's not the case with a view that's not a view group. So an edit text is not a view group, it's a view. An edit text object at runtime does not have nested within it other views. And consequently, the attributes and the properties, or the properties associated with an edit text, have different meaning than the attributes or properties for a layout or a view group. So in this particular case, the layout's width is to match the parent, fill up the full screen, and the height, match the parent, fill up the full screen. And then let's do 16 density independent pixels at the bottom and the top to do padding, right? So padding bottom, padding left, padding right, padding top are 16, which gives us a border all the way around it. And then the context is main activity, which is our class that is the controller. So let's take a look at each of these different components. There are, if we go back to the emulator, and let's cause this guy to execute. So I can point out the view, the components on the view, and how we specify the different things about them. So we have an edit text for title, an edit text for released. Let's look at here's the edit text for title. We've created an identifier for it called title ET, edit text, and we've placed a hint. So you can see that my hint is a string. It shows me that it looks like actually the hint is the literal string title, but in reality there is in my strings.xml, what it actually is stored there is at string title, which means if I go back to the project and look in the values, resources, values, strings.xml, you will see a string named title, lowercase title, whose value is capital title, which is title, which means, as I mentioned before, and will continue to mention until everybody's answered it correctly on an exam, in Java and Android, strings are objects, and objects are not as efficiently handled as primitive values. In order to make it more efficient, all of the strings that are literal strings within an Android app are suggested to be placed in the strings.xml file so that they can be allocated as strings one time and one time only in the execution of the app and efficiently accessed as well. So for example, if you included a literal within an iteration that executes 10,000 times, then in fact within, depending upon the Java runtime environment, whether or not it did any optimization, there may be a new called every time through that creates that new literal string. Well, this makes a much more efficient mechanism for managing strings. So my activity layout main, the hint is title. And if you notice on the view itself, title is really just a hint. It's not text that's in there. It's shown, but not actually. If I were to read from the program, the contents of that edit text at this point, it would not have anything in it. So when the user puts focus into that particular control, a keyboard comes up. And how does it know what keyboard? Well, if you look, title has a keyboard that has the full QWERTY keyboard, all the characters, the ability to also have numbers and punctuation marks as well. But when I go to the released edit text, it does not. It only has numbers and a slash. So the released is intended to enter a date. And the title is intended to enter any alphanumeric text. And the way that is specified is by providing a value for the property input type. So I've entered input type text for the title input text, and for the released input text, I've entered a type of date. Right? So the keyboard that gets displayed to the user depends upon that property or attribute input type. You can either set it in the designer over on the right-hand side, or you can just set it by specifically entering it into the XML if you want to. Other things, all right, the hint is there as well. And then I'm also giving it an identifier. All right, so we have a text input type, we have a date input type, and then the third one, which is the genre, is also a text input type. And the fourth one is a little bit different. The fourth one is a multi-line, right? So it is an edit text, but an edit text in the Android API can be for multiple line elements or it can be for a single line. Different than the way it is in actually most other frameworks for user interface. Instead of having a subclass of edit text in this case, in fact here it is all taken care of with edit text. So I say that it should display 2 lines initially, maximum number of lines is 2, that it doesn't scroll horizontally. In other words, when it gets to the end of the control, actually it will go down and use the next line. And then you can see it line on the parent left and align parent start. Both of those are true. Margin top, I think I've used that in all of them to have 10 pixels, density independent pixels as kind of a buffer between spacing between each of these different controls. Again, the type of keyboard that appears when the user places focus into that particular control depends upon the input type. I think the default is text, and if you specify something different, then you'll get something different. And notice that in the case of the multi-line, I've specified input type text IME multi-line as opposed to text because I want to be able to enter separate lines. It's pretty straightforward. If under program control you want to put multiple lines into a multi-line edit text, or you can do that by just putting a \n, an escaped new line, in your string, and it'll go on to a separate line. But actually getting that to show up in for the user to be able to enter it is a different story. So if I have John as one of the artists, and I want to enter another artist, notice if I do the check, I end up with not the ability. There's no new line. All right. So let's go back and erase these. How do we do it? Well, there is no way with the way that this is currently set up to do it. I did, however, put some comments in the code for doing it. So genre, maybe rock. And notice in this case, the greater than it's not a check, it's a greater than, which will take me to the next control. So when the user selects the greater than, it takes them to the next control. And then when they select the check mark, it dismisses the keyboard. All right, so I can enter the title. And then enter the release date. And again, tab onto the next control, and tab onto the next control, and then check will release it all. So the user, it facilitates the user entering information that they need to enter. So let's take a look at how one allows the user to enter multiple lines of text. In order to do that, let's go back in here in the main activity. So here's a note in the comments of the main activity about using the virtual device manager in order to edit the keyboard that's being used. And then the next comment is about multi-line input. Here is the if I provide a Android input type, text IME multiline allows the keyboard to be dismissed but unable to enter a new line, which is what I've currently got in there. But if I do text multiline, can only dismiss with the device back arrow. All right, so let's change our to a text multiline, rerun it. And now let's look at the keyboard that we get. So now John, and if I hit, N, John, if I hit the new line, I end up getting the second line, Bob. So if I hit another new line, I'm going to get another new line. And notice that not only did I get another new line, since I specified only 2 lines, John disappears. All right. However, also notice that now instead of my diamond being left, or instead of it being a left arrow, it's a down arrow, which provides for me the ability to dismiss the keyboard. All right. So by using text multiline, I have the ability for the user to enter multiple lines of input, and then in addition to that, to also dismiss the keyboard. All right. So there's an example that shows that. I wanted to show you that part, and then just to by way of so here's another example that I wanted to show you. That's so on the web page there are alert view. We probably won't look at that, but I want to just briefly show you autocomplete text. Cancel. I don't want to download it. When you download it, I've already got it opened up, and then spinner with JSON. So a spinner, you'll see how to do JSON serialization and deserialization using org.json. But let's take a look at the autocomplete text. It's actually a very convenient approach for using an edit text that allows you to provide a hint or do prefix matching within it. So we've got that autocomplete, and let's go ahead and run it. So here we just have a single edit text, and that single edit text is, the hint for it is courses. So if I put the focus in it, then it shows me a spinner that has all the different possibilities. However, if let's get rid of some of the characters here. All right, so if I don't enter any characters, it shows me all the different possibilities. And if I enter just one of the characters, spastic hands here, if I enter just one of the characters, in this case it's either a C or an S, it shows me the possibilities, right? So it's not distinguished, but it does prefix matching based upon all of the different possibilities that are given as potential input for it, or the user can enter something completely different. All right, so that's a course that is not in my autocomplete list. So let's take a look at the code. We'll just finish with looking at the code for this one to be able to set that up. There's a little bit involved in doing that, although not a lot. So in order to do that, whether it comes from a static array or any other collection of the potential values that can be entered, or for which you want to do autocompletion, it may come from a database or it may come from any other model source of the things that will make the typing, will decrease the amount of typing that the user has to do. That's exactly what you want to do in a mobile app because typing is a pain in the neck. So in this particular case, that model comes from a string array. And I use that string array to create an adapter. All right, so the base for the adapter, so I create a course adapter, which is defined up here. Course adapter is an array adapter of strings, new array adapter, and then use the constructor, android.r.layout, simple drop-down item, one line. This is a predefined layout within Android that provides for a simple drop-down list. And notice that I have courses ACTV, which is Autocomplete Textview. So there is within the Android API a control. It extends Textview, which is called an Autocomplete Textview, and I can associate with it an adapter. So courses ACTV set adapter to the course adapter. And then I want to be the on item click listener for it, me being the activity, this being the activity. And I want to do edit action listener as well and on touch listener. And then I can also set a threshold for it as well. All right, so this shows you how to set up, and notice that that's done in the onCreate method. So when the activity first gets created, we set it up. Of course, we have to populate the view, which is set content view to activity main, and then we find courses ACTV as an alias or a reference to our autocomplete text view by doing the find view by ID, where I've set up the ID r.id courses ACTV, right? So R is our resources class that's automatically generated for us, and then within it I've created that ID. And just to go back and take a look at that. Enter resources, layout, autocomplete. I've got an autocomplete view, and its ID is courses ACTV, autocomplete text view. Okay, so to show you two different approaches, one to control the type of keyboard that gets used for user entry, and then another one which strongly encouraged to be used, the autocomplete text view, where you can do prefix matching to allow the user to type as little as necessary, and it has the additional capability of allowing the user to completely enter separate information if they want to anyway. Let's leave it at that. Again, let me just point out this is a recording that's in Unit 3 on the basic user interface for Android. And again, there are 4 examples. 2 of those we just looked at, the autocomplete text view. There's also one on doing alerts, which is essentially a pop-up to give the user a message or even get them to enter information. Input text, that's the one we also looked at, and then using a spinner in conjunction with JSON. So that'll be it for today. Thanks.